Hi everyone, this video is going to cover writing equations of parallel lines. We're only going to look at parallel lines in this video, not the perpendicular lines. So first thing that we're going to do, and make sure that you pause the video as needed because I'm going to go through these first slides pretty quickly, probably with not enough time for you to write everything down. So make sure that you're writing everything down by pausing when you need to. So if we were to draw two parallel lines, most of you might have an idea of what that is, or what they would look like. If I were to draw two parallel lines, I could have one right here. And you can, in your notebook, you can just draw an X and Y axis. You don't need to label it or anything. And another parallel line, do it in a different color, could be, let me change that, there we go. Oh, they look pretty parallel. So those are two parallel lines. And you can see that they have something in common. They look similar. So what could we say about their slopes? Well, remember that the slope is the rise over run. And again, we don't really need to put values to this, but we can see that since they tend to be decreasing by the same amount, that the slopes are going to be the same. And their y-intercepts are going to be different. So that's what defines parallel lines when we graph them on a coordinate plane. They have the same slope, but they have different y-intercepts, and that distinction is important, that the y-intercepts are different, as well as that their slopes are the same. So the properties of parallel lines, just make sure that you write this down. Parallel lines never intersect. So if we can continue these lines forever, they would never cross as long as they were parallel. Parallel lines have the same slopes. We talked about that before, but different y-intercepts. More properties of parallel lines. All horizontal lines are parallel to each other with a slope of 0. And all vertical lines are parallel to each other with an undefined slope. So undefined slope. So first examples, we're going to identify which of these lines are parallel. At first glance, for part A, they all look parallel. The graph is kind of zoomed in, but we can determine for sure by calculating the slopes. So looks like my scale is normal. That's the first thing that you always want to check for is your scale. Looks like we're going up and down and right and left by 1. So that makes things a little easier for us. Always start on the left point, and I'm going to find the slope of A. And you know what, I'm going to do this in blue actually, because line A is in blue. So I'm going to use a little subscript for A. The slope of A is what that means. So we go down 1, it looks like. So I'm going to write -1 there. And to the right, 1, 2, 3, 4, 5. So my slope for the first blue line, for line A, is -1/5. For the red line, looks like we're going down 1. 1, 2, 3, 4. So the slope for B is -1/4. And for the last one, down 1, and 1, 2, 3, 4, 5. Okay, so the slopes that are the same are A and C. So line A and C are parallel.